the increasing order of pKb. Now what is the pKb? For convenience, the strength of base is determined by pKb value. Stronger acid have smaller the pKb value. How I know? See, the formula of pKb is equal to minus log pKb. Kb, it is dissociation constant for base, and dissociation constant is equal to the concentration of base. Base means it gives hydroxide ion. If the stronger base has the more and more hydroxide ion concentration, but if the basicity increases, the pKb value decreases. Same as for acid, we can write the strength of acid is determined by pKa value. Strong acid has smaller the pKa value. How? The pKa value is equal to minus log Ka. Ka is the dissociation constant for acid. It is equal to of hydrogen ion. The acid give proton. Now the strong acid has higher concentration of H plus. That means strong acid has smaller pKa value. We can write the relation between acidity and basicity. The acidity is inversely proportional to pKa value and inversely proportional to also basicity, and basicity is inversely proportional to its pKb value. Acidity is directly proportional to pKb value. That means if we find the acidity order, then it will be the also pKb order. How to decide strength of acid? See, here acid is present. After deprotonation, it gives H plus and A minus. This is the acid. The anion is called conjugate base of acid. Strong acid gives most stable conjugate base, and weak acid give less stable conjugate base. What is the meaning of most stable conjugate base and less conjugate base? Most stable conjugate base is because negative charge in conjugation. Remember, only the negative charge is stabilized by electron withdrawing group. That means the minus I, minus N, or minus R, or minus H group. This right side portion all are phenyl, but the left side, this different substituent will decide the acidity of this compound. If this compound lose its proton, that means it is acidic. After lose this hydrogen, the nitrogen bears negative charge. This negative charged molecule called conjugate base are all conjugate base of acid. If conjugate base is most stable, that means it is strong acid. Which negative ion is most stable? Negative charge is most stabilized by electron withdrawing group. The powerful electron withdrawing group can stabilize negative charge. NO2 group is electron withdrawing group, and OCH3 group is most electron releasing group, because the lone pair in conjugation with benzene. Nitrogen negative charge can move here. Carbon bear negative charge, and this negative charge is directly stabilized by this electro withdrawing group. But here the negative charge come this carbon. This is the electron releasing group. It cannot stabilize negative charge. That's why this conjugate base become most unstable. And this unstable or less stable conjugate base have weak acid. Now we can see if electro withdrawing group give strong acid and electron donating group present, then it will become weak acid. Now the NO2 group is most electron withdrawing group. Okay, then the fluorine is electronegative. Then releasing group are OCH3, methoxide and methyl group. This group show plus M effect. Okay, and the methyl show plus H effect. That means the negative charge is most destabilized by mesomeric effect. OCH3 group destabilize most to conjugate base. The acidity order C is most acidic, then A, D and the last one is B. Now acidity is proportional to pKb value. That means the acidity order and pKb value order is same.